Hi, good morning. Thanks for joining me in my shop here. Today is June 5th. Going to be the first really kind of sticky, humid day here in Aurelia today. Enjoying the heat. A great rain. Thank God we got rained on. Oh my gosh. Now, what I'm going to be doing today is changing some of the capacitors in the radio. I'm going to go after this burned resistor here. But before we get into that, I just want to just poking around this old book here. It's not that old actually. It's from 1943. That's not that old. 1943. There's a section here on eliminating interference. You might think, well, what interference are they fighting back in 1943? Well, it's things like fan motors and stuff like that. There's an interesting list here. It mentions the violet ray machine. I don't know, have you ever seen a violet ray machine? But here's a list. Here's a list of things that cause interference on radios in 1943. Vacuum cleaners, sewing machines, fans, other household appliances. There was a longer list here, I thought. Oh yeah, here it is. But you listen to the kind of noise, you can track it down. Crackling and humming can come from cash registers, drink mixers, elevators, electric refrigerators. That would be as opposed to non-electric refrigerators. Electric fan, sewing machine, vacuum cleaners, and washing machines. Dish and clothes. If you hear a buzzing sound, that could be from doorbells, dial telephones, elevators, oil burners, sewing machines, and whoop, vibrators. Okay, okay. Clicks. Elevators. Who's living around all these elevators? Elevators, flashing signs, defective heating elements, defective light bulbs, defective switches, flashing signs, and traffic signals. Crowded neighborhoods and apartment buildings. So that's what they're thinking about. People living in apartment buildings. Yeah. Here we are anyway. Let's get a kick out of that. Doesn't list computers in the list, or modems, or wall warts, switching power supplies. All that stuff is missed. Boy, they think they had a problem back then. I wish the world were now the way it was back then when it comes to these radios, because noise interference was minimal. Definitely minimal. Now, big challenge here with changing these capacitors. Most of them are so messed up on the surface, you probably can't read the value right off them, especially this one that's chewed to death down here. So maybe I can relate the schematic to the individual component and figure it out that way. Probably going to be a combination here. This resistor, and it's what I'm sure is its bypass capacitor. This should be pretty easy to find this on the schematic, but from there, a little bit tricky, and I'm just going to pop the schematic back up on the screen here and see if I missed some important information. Okay, let's look for the oh, where's the cathode resistor? There it is, right there. Are they showing the bypass capacitor? What's going on here? What is going on here? Well, so it looks like the speaker is connected across this winding here. This other winding would be like a feedback winding, but it's heading into, yeah, it's heading into all this, the tone schmozzle. So this is similar to the last radio I did. The feedback, and then where's the volume control in here? That's the volume. That could be tone control. Which one's which? Uh-oh. We're not gonna... this isn't gonna help us too much. Well, boy, I could give them awful lot of things wrong here trying to figure this out. So that looks like, what does that, let's zoom in here. This might be a lot more difficult than I thought. So that says 200. It's probably 200 ohms. Gives a voltage right there, 7.6 volts. That's the bias voltage. 50 microfarad capacitor sitting here. It must be very low voltage though, because it's small, physically small. Again, it's got this point here. I don't know what this means. G and green, blue, General Electric, shortwave. Okay, well, I have to assume. I mean, this must be a bypass capacitor. It's a big one. It's in the right place. Just because it doesn't go straight to ground, it goes through here. I don't know. I don't know how these windings are. I don't know what's going on here. It got me. I don't know. So, but we got the sizes here. Now, other capacitors, they've written the sizes right in here. 220 picofarad, 10 nanofarad. Probably some of those capacitors I can read, one or two of them anyway, and those I'll know, and the rest I can eliminate those maybe. Oh boy. Let's see if we can track down even one of these. Look at the capacitors around the output transformer. A lot of resistors and all kinds of stuff. Right up. You know what this might be? This might represent the plug of wires. No, I don't think it does. There's too many. I don't know. Okay, Garrett, get back to what you're doing here. What am I doing? I'm trying to figure out a couple of capacitors. Let me get it on. Tell you what, I'm gonna get it on this. I'm gonna fix things here. Okay, got it up on the screen now. We can look at the radio and the diagram at the same time. See if that's going to help out here. So it's really these three capacitors I'm trying to sort out. This one is tied right to, well, this isn't going to help. This plug is not identified clearly on the diagram. For a minute there I thought it was maybe the dashed line represented. No. So I haven't found where this plug is clearly identified. See all these wires here making connections here. If they draw on a dashed line around the transformer, then I can't relate. I'm trying to relate the physical stuff here to something on that diagram. It's not working out so well. Wow. Look at the actual wires coming out of the transformer here. Most of them, but not all of them, go up into these terminals. Some of them actually go downwards into the radio. So, knowing primary from secondary. This is a that's very odd. These are multiple conductor cables here. So this one's split. Oh, no, it's not odd at all. I have two conductor cables splitting up here. Who's coming after me on my phone? Okay. Just notes from my family. Well, these have to be intimately involved with the sound side of things, with the speaker side of things. Oh my gosh. You know what? I'm going to trying to sort this out. Oh boy. Let's take a real close look at these and see if I can't identify their sizes. And then they can do physical comparison. Let me switch here. Okay, let's take a look. See what we can see. Just improve the focus. Well, looks like I'll be able to read this one. Well, 250 volt. Oh, there it is there. 0. Well, looks like 0.4. That's kind of weird. 0.04. Something like that on the schematic. Looking for a 0.04, maybe that'd be like a 40 nanofarad. 40 nanofarad. Didn't see anything like it. Like, where are all these capacitors? There's really none around here on the diagram. There's these close to the tube here. Well, that doesn't help any. It's all part of this schmozzle down here. Who knows, you know, where the components are physically located when you see them on the schematic here, and they can be 10 and 10, 10. Where's a 40? 47N. Looks like. 40 would be a weird number. 47 is what you would kind of expect. Well, this isn't working out very well because I'm going to find one on here and I'm not going to know if the one I found is the one I'm looking at on the radio. There's no parts list, eh? Parts list. Is there another page somewhere? You know, there could be another page somewhere. Yeah, and then there's that warning. There's a difference, but the differences are probably not in these components. Well, that's the wrong end of the radio. So this method is not going to work very well. The next step really is a one-by-one thing. Cut the capacitor out, examine it very carefully, try to find a number. Can't find the number? Try to locate it on the schematic very carefully. Put all the time and effort in to do it. The other alternative is to take a guess at the size. How would that work out? So a lot of these are very similar in size, like this one, and this one up here. This one down below looks bigger, quite a bit bigger, in fact. So I get one of a certain size and read the number on it. You know, I could assume the others of the same size. I'm looking at this situation down here. Wow. That is just unbelievable. What happened to that? It almost looks like cut by tracking, but usually the edges of tracking are burned. They're carbonized. The track is carbonized. We don't see that. Holy smokes. I'm just trying to imagine what happened to this. And what about looks like the underside of this one just above it. Let me move the camera around here and get a shot of the underside of it. Like, did that guy get cooked? Because this one, again, was on fire. Oh my God. Like this particular type of capacitor, this brown style you find in these radios, often do look just like this. They look really bad. But not like that other thing down there. So this is not going well. I'm not getting any hints here. Not getting any warm feelings about how to do this. I can certainly attend to this though. When I get something done here, let me deal with this. First of all, what's the resistance of this resistor? Even though it looks horrible, it may still be the right resistance. To do that, I need this guy here. Eh? Okay, my meter's on the 1000 scale. Doing this in circuit. $300. Well, that's a very significant difference from 200. Can we actually see the colors on that thing still? No. Let's cut it out. My parents used to say that to me an awful lot. Cut it out. Were your parents like my parents? Absolutely intolerant of any nonsense. If they asked me something and I began to give a nonsense answer like a little kid does, they wouldn't get anywhere before they just shut me down. Nonsense. I think there's a lot of people in this world who could use my parents' guidance right now. I guess the only way you can get it is through me. Yeah. She's cooked up pretty good, yeah. We'll take another reading here, just to know for sure now that it's out. But the circuit it's in, as a cathode resistor, is a dead ender when the radio's not operating, so the reading should have been perfectly fine. Hard to believe it's still conductive at all. It reads it just a wee bit lower than it did in the circuit, which is kind of weird. And what happens if I push on this or flex it? She's rock solid. Okay, I can read the numbers. The numbers are completely visible, in fact. There's really no problem at all. Just do it myself here. So that looks like red, black, and I would say that's orange, the third band. Well, that's not 200 if that's orange. That would be brown. If it were brown, that would be 20 with a 0, 200. That's a brown. That's 200. 200 reading 275. 200. 200 is the winner. Bit of a long decision-making process. Okay, I'm going to stick a 200 in there. Wait a minute. What about that capacitor right beside it? You do these together. So one thing I didn't talk about was a decision to do the work from above or to do the work through the board and solder up from below, like it is originally. The first resistor is up on posts, so that's got to be done from above. But for this capacitor, I have a choice. I can try to fish the leads, like desolder them underneath, drop them down, maintain a clear hole here, put the lead of the new capacitor through the hole, solder up from underneath. I can do that, or I can just cut the leads here and there, leave the leads sticking up. Don't worry about what's underneath. I just solder the new component to the sticking up leads, which is my preferred approach because you're doing less. I like doing less. Okay. So we're going to cut it out of there. So I'm going to cut it out now. Be smart this time and keep track of which end's positive. I can't tell right now. I think this is the negative end, but I really can't tell. I'm going to cut it out. Leave. Don't cut it flush. Leave leads to work to. Back here is not so spacious. Not so much lead, but enough. Okay, let's take this one out and take a look at it. Well, there's the heat mark, but it's really not of any great significance. Oh, the end here looks really rough. I'll put it on the close-up. Okay. Oh, that looks like the insides have pushed out, doesn't it? Looks like it's popped its cork. That's what it's done. He popped his cork. This side actually looks okay. Well, we get the 15 volt. We're getting the news here. It was a 50 on the schematic. 59A, 6 point. There's the plus end. Where was that end? where was that end? Oh, I think it was definitely this way, because I didn't see this egregious stuff. I would have commented on it. Gotta be this way. So positive end. Let's just double check now, because this is the part where I always get this wrong. It's just, I don't know what it is. Emotional instability. I don't know. Okay, got the positive idea where it is. Now, value 12 and 15 volts, 59 amps, 6. Oh, we're into the black here. I think that says microfarad, and then the number is under the black. There's part of the number. I would say that's a 0. I could say 50. Could easily say 50. Can I cut this stuff away? Yeah, you know what? I'm going to try to peel off this crazy stuff. But, I mean, it's all about having a bit of fun here, right? Switch cameras. Always about having fun. And, you know, for me, this is what fun looks like. Doesn't take much. Okay, what happened there? I think I grabbed the metal. You think it's printed right on the can? Fun? Wow. Do you live around Buffalo? You know why I'm saying that. Fun? Wow. Let me just clean the black off. No. Well, the first part was easy. My fingers are in stabbing range here. I can't get that off. There it goes. I've scraped everything off of it by the time I get this coating off. Yeah, the words are on there. They were on there. I'm 99% sure I should put a 50 in. I mean, I can't go too far wrong, can you? Put a big one in, start some motorboating. Yes, a private joke for me. Okay, let's put this under the close-up camera here and take a good look at it. Yeah, I watch lots of videos on YouTube, and a lot of the presenters are overly excited. 59. That's the voltage thing. And it disappeared. Well, why don't we test it? Why don't we test it? That sounds like fun. Let's test it. We'll give this guy a try. So it's 880 picofarads, so that would be a 0.0008. That's a lot smaller than 50 microfarads. What the heck happened here? This is definitely an electrolytic capacitor because it has a plus on it. It looks like it. There's no question. It's gone. It's gone away for, it's popped out. It's a piece of junk. So zero capacitance. So we have a high resistor with no bypass. That just sounds like a really bad combination. Okay, new resistor and new capacitor are going to go in there. I had to rummage around a while, but I found one here. It's 100 volts. It only needs to be 15 volts or so in that spot. 50 though. 50 microfarad. Let's just check them. It's NOS, so take a look. 50 microfarads. Oh, good. That's good. That's good. Okay. And that's the capacitor now. Did I not grab it? I thought I grabbed the resistor, didn't I? Maybe I didn't. I'll give myself a resistor here. Okay, found myself what has to be a high enough wattage resistor. Is it the right value? Let's just be sure. 200.9. Great. I think we can live with the 0.9. So I got the two parts I need. I'm going to just install them. Well, as it turns out, special attention is needed. So I've had to bring out one of my Scandinavian fish knives. Yeah, this one's not that special, is it? Where's my special one? Yes, let's use the... Now there's a real Scandinavian fish knife. I'm now going to use it to scrape the wires here a little bit. So they'll make a better connection. I just thought it'd be fun to see the fish knife in action. I'm not a fisherman. So I live on a lake called Lake Kuchiching. It's just north of a much larger lake called Lake Simcoe. It's a very large lake, seriously large lake. And that lake has the best bass fishing in the world, and has forever. Because I believe it's full of timber down the bottom or something. I don't know why, but for some reason. Okay, that's that one. This lake looks pretty good actually. Okay, capacitor first. Positive leg up towards the top. Need to shape it a little bit. Whoa. Distance. Okay. There's my stronger pliers. There. Very good. I'm rushing a little bit now because my wife just reminded me we're off to my mother-in-law's apartment in the nearby city of Barrie for me to install a brand new window air conditioner because the weather is changing here. We've had really very low humidity, crazy low humidity the last while, probably because in my area there's been no rain forever, and but now that's changed. We're getting some southern air coming up from I was going to say Mediterranean. No, it's not coming from the Mediterranean, Jim. It's coming from the Caribbean area. But what I wasn't paying much attention to what I just said, so I hope I didn't say something stupid. Now, occasionally when you're doing this, the wire, that just happened, the wire you're soldering to comes loose underneath. Also, the heat goes right through. So you just have to kind of hope you're not desoldering it underneath. There we go. I'll get back on the other side here. Probably can't see much in the camera, except a lot of smoke. This one also came loose. There we go. Capacitor in. Now the resistor, it's a very large leads here, so I'm a very large post, so I'm just going to tack it. And right here is frayed wires here. That's not very good. Frayed wires from a nearby cable. Why do these all come loose here? There's all kinds of loose wire right there. Let's de-loose it. Okay, now, Mr. Resistor. Mr. Resistor. Close but not quite. Okay, we're going to tack in the closer one first because it's easier. Yeah, I was afraid of that. You know what I didn't do? Looks like the solder's grabbing it okay, but just in case. Okay, another attempt. Put some fresh solder on this, but what I'll do is I'll come back on it once I get it to stay. Doesn't look I could stay in at all. Okay, that's enough for now. Where's the other terminal? Okay, I gotta take this resistor off. Side. This just isn't working out. It's running away. So I'm just trying to get it to hold on one side while I do the other side. There we are. It's still too far over. How hot is it? Is it hot enough to burn my fingers? That's a way to find out. It's such a heavy wire on this resistor lead, I really can't bend it without tools. It's not working out. Okay, that's in position. More or less. It feels so loose now. It's whatever's happening underneath the board now is desoldered underneath the board. So much for this. It's supposed to be a time-saving approach here. Go over here. Come on the other side. Trying to get it to spring against the contact. There. So then when I heat it up, the spring force will push the contacts together instead of pulling them apart. I shouldn't even need to put a tool on it. That's it. Is that enough monkey business on this resistor? Now it feels solid because it's been solidified at the other end. Still got to check underneath and see what happened here. Maybe that's a general rule anyway. Can we flip this right up on its face? Apparently yes. Okay, now looking back, my finger here. Oh, it's way the heck up there. Way up there. Let's switch cameras here. So I'm going to wiggle the resistor. I think I can. There it is, right there. Wasn't a lot of solder on it. That must be the other one right there. Well, you know, this could have, you know, been made brittle from heat. Too much heat during the earlier conflagration, whatever happened in here. Okay. Okay, I think that got it. Let's take a little look. Very hard to see up there. Yeah, it's definitely got it. What's going on up there? That looks like maybe the capacitor lead that I did. Okay, here we go. No. And it looks like it's not soldered. Barely soldered. Well, whatever it is, I'm going to hit it with the soldering iron. Okay, let's take a look at that. Okay, that's better. Okay, there we are. First capacitor and resistor done. And that's the bypass capacitor and cathode resistor for the output tube. Again, the resistor probably took a beating because of another failed capacitor, not protecting the grid of the output tube from the ravages of B+ leaking into it. And then probably this resistor ran hot. This event would have developed over time, wouldn't happen suddenly, develop over time slowly, getting worse and worse and worse, hotter, hotter, hotter during the time, cooking this guy up. So he ends up having no capacity left. I guess that's what happened to it. And then the actual capacitor that's failed, I mean, you gotta guess it's this incredibly ugly one here, but that's just a guess. Yeah. Okay, well that's good. That's 2 parts done. 2 parts done. 15 to go. Thanks a lot for watching.